I wanted to make this recording for you on trigonometric functions, just to give you a more complete view of what we're really talking about. So I've decided to draw the triangle a little bit differently in order to fit in with your discussion of functions earlier in the class and the fact that we typically use x to designate the domain and we use y to designate the range. And so I'm going to speak to that in this discussion. Look at the way that I've done this. I've created a right triangle, ABC. The way that we like to talk about this is that if you have vertex A, vertex B, and vertex C, and then look across the triangle, you can see little a, little b, and little c, respectively, being noted as the lengths of the sides BC, AC, and AB. As we continue this now, recognize x is going to be an angle measure that is somewhere between 90 degrees and 0. And notice it can't equal 0 and it can't equal 90 degrees, and so this is just going to be an acute angle, angle x. And so when we do that, we have been taught that trigonometry says that the sine of x is a ratio, and that ratio is going to equal the length of the opposite, which is A, over the hypotenuse, which is C. And I'm going to go ahead and call that y equals. And so now we're talking in forms of the function, where the function has the domain of 0 through 90, but not equal to 0 nor 90, and that's x. So everything that x can be is the domain, and it's some value between 0 and 90 degrees. And then y is going to be the range. And so the range is going to be this value that is actually calculated by taking two numbers and creating a ratio. We have a over c as that right there. So similarly, we're going to be talking about the rest of the trigonometric functions, and the basics are y equals sine of x is equal to a over c. Cosine of x then is going to be the adjacent, which is b over c, and the tangent of x is going to be the opposite over the adjacent. So that's where these come from, this idea right here. Now, x is the domain, it's some value given in degrees, and the range now is a ratio. It's a comparison of a over c, b over c, and a over b. So you can see these as like maybe some decimal representation 4 digits past the decimal if you want to talk about them as an approximation. Or we'll be able to also express them as exact answers as we use radicals in creation of the ratio. So you'll be seeing that as we go. So since we're talking about functions, we're actually also talking about inverse functions. And inverse functions basically are asking the question like, what value of y gives me a certain value of x? So if these are trigonometric functions, then now we also have to talk about the inverse of trigonometric functions. You remember the discussion of inverse functions. We start off with, let's just do this with sine. If we have y is equal to the sine of x, right now the domain is x and the range is y. But the first thing that you do in creating an inverse function is you swap x and y. So we're going to say x now is equal to sine of y, and then you solve for y. Now in this case right here, solving for y means I need to take the inverse of the sine function. So I'm going to say then y then is equal to the inverse of sine, which is a different function than just sine, because what it's going to do is it's going to take this value of x. Now recognize this is a ratio and this is an angle. So as we do this now, we're actually saying what is the angle that I get when I see this ratio for sine? So this is how you have to think as you're talking about inverse functions. We'll be thinking about that as we go in solving the problems. Here I'm going to show you how we can use a simple triangle, and I know that in this case right here, if this is a right triangle and one of the acute angles is 30 degrees, you have this situation where the opposite is going to be half of the hypotenuse, and then the other leg is going to be whatever the length of that opposite is times root 3. So we can simply say this then, that if we think about the y equals, if we wanted to know what the ratio is going to be, y is equal to the sine of 30 degrees, then we end up with the opposite, which is 2, over the hypotenuse, which is 4. Well, that reduces to 1 over 2. And so we have then that the sine of 30 degrees is going to equal the ratio 1/2. So there we are. We have the sine of 30 degrees is equal to the ratio 1/2. That means then if I wanted to find what is the inverse sine of 1/2, so I'm putting a ratio into the inverse function, I get an angle, and that's going to be 30 degrees. Let's go ahead and punch that into a calculator and show how that works. So here in this calculator that you see on the screen, make sure that we're in degrees. Right now it's in radians. We want to make sure that we're in degrees, and so always check your calculator when you're doing trigonometry to see that you are in radians or degrees. We need to be in degrees, so we are right now. The way that this one works, I can hit 30, which is the degrees that are given to me of the function, and I'm taking the sine of that 30. And notice I get 0.5. 0.5 is the same as 1/2. If I go second, notice sine now becomes the inverse sine. Now we're going to do it the other way around. If I take 0.5, so I'm just going to punch that in because it's there right now, but I'm going to say 1 divides 2, which is 1/2, and say equals, and say 0.5. And then let's hit the inverse sine. Well, do you think we're going to get 30 degrees? We'd better if we're doing this correctly, and sure enough, we do. That's how that works, is that you can take the ratio, put it into the inverse of the function, and get the desired result. Solve for x. Well, x, with the way that that's being placed, is in the position of what we would normally call an angle, right? So we're looking for an angle measure if 3 is the length of this side and 7 is the length of this side. So what do you think we're going to have to do? Well, trigonometry says that 3 is adjacent to x and 7 is the hypotenuse. And so we've got adjacent over hypotenuse. Well, that's cosine. So we can say the cosine then of x is equal to 3 over 7. But we need to know what x is, and so we're going to say the inverse cosine of 3 over 7 is equal to x. So now let's go ahead and solve for x. So we're going to bring up our calculator here, and we're going to say, what is 3 over 7? Well, that's equal to that number right there, and then let's take the inverse cosine of that, and we get 64.6, which rounds to 65 degrees is x. And if we click on it, we got it. Let's try another one. Solve for x. So solving for x here says we're looking at x is the angle again, and opposite the angle is 11, and the hypotenuse is 25. So we know then that we're talking about sine, so we're talking about the sine of x is equal to 11 over 25. So that means if I wanted to know what x was, I could take the inverse sine of 11 over 25, which is the ratio. So if we do that now, we're going to take 11 divide by 25 and take the inverse sine of it. And we get 26 degrees. Is that one of the choices? 26, that's A. We got it. So A is the answer to that one. Let's keep going. Here we're looking at solve for x. If x is this angle right here, and this length is 2, and this length is 1, and both of these are legs. So I've got the opposite leg is 2, and the adjacent leg is 1. So we're really talking about tangent. So we have this right now, tangent of x is equal to 2 over 1, which is just 2. So if I take x and I take the inverse tangent of 2, what do I get? Let's see, inverse tangent of 2. So we're going to say 2 and take the inverse tangent, and I get 63.4. So 63 degrees. And sure enough, there it is at the top. 63 is A, so A is the choice again. All right, there's a few right there. Let's see if you can do some of the problems on your homework now.